So today we would be discussing covalent bonding and metallic bonding. So let's start up with first we need to review what was a bond. So a chemical bond is basically any kind of force of attraction, and if we are working with let's say a covalent bond, so this is obviously since it's a bond, it is also a force of attraction. But if we are working with covalent bond, then we need to understand that this is force between atoms that results from sharing of electrons between them. Now, the first idea that needs to be understood clearly here is, let's say if you are talking about why would an atom be sharing its electrons. So to answer this question, what we need to understand first is, let's consider if we are working with the basic rules of stability. They were either duplet rule and the octet rule. That means atoms tends to become stable by either having two valence electrons or either having eight valence electrons. Two valence electrons or eight valence electrons. That means atoms, they are not stable by themselves. A very few of them are stable by themselves, but they need to become stable or they tend to become stable or to establish this noble gas configuration what we have learned previously. This is duplet rule and octet rule accordingly. So for instance, let's apply duplet rule on one of the atoms, let's say. So consider hydrogen atom. We all know that hydrogen has one electron, and from where this knowledge came from, through the periodic table. Since hydrogen has the atomic number of 1, so we can see that since it's a neutral atom, it obviously would be having only one electron that equals the number of protons inside. So if let's say this represents my hydrogen atom, so now I'm using a symbol to represent this valence electron, and I'm creating a dot here. This means that this dot here represents the valence electron. I can also use a cross here. Let's say this is hydrogen here and there is a cross here. So this can also be a representation of its valence electron. So this model of studying chemical bonding or this model of studying the atomic structures is often referred to as dot cross model. So if now we need to understand that, let's say this hydrogen decides to become stable, or this hydrogen, this is some other kind of an hydrogen atom, this decide to become stable. So what rules apply on this? So duplet rule applies on this, these two atoms. That means they need to have two electrons in their last shell, and we can only see one electron here. So if they tend to become stable by having two valence electrons in their outermost shell, then either this hydrogen, it needs to gain some electron from another atom that is willing to lose the electron, or either it looks for an empty electron anywhere in the universe, or either it bonds with the other hydrogen atom to temporarily satisfy their valencies. Let's say if we consider this, for example, in a market, there is a commodity that price, let's say, equals to, for example, $100. And if I, being a teacher, wants to buy that commodity and I only have $50 in my pocket, so would I be able to buy this? The answer was obviously no. I won't be able to buy this. Reason? Since I am lacking my $50. So what I do is I borrow some $50 from my other friend and I bought this up. Now, if I ask a question, to which of these two persons, either me or my friend, this commodity belongs to? The answer is obviously it belongs to both of us because I borrowed something. And to be very accurate, I borrowed exactly the same amount. He or she is the 50% partner of my commodity, whatever I bought. So idea that needs to be catered here and understand clearly is this bonding here. that keeps us together in using this $100 commodity is basically now in chemistry referring to as a covalent bond. So let's apply the same, for example, on hydrogen atom. If we are working with hydrogen atom that carries only one valence electron, and let's say it is basically unstable here, and there is one more hydrogen atom somewhere in this universe that carries one valence electron, and this is still unstable here. So if both of them agrees to share their one valence electron, and result is that they may have made now that this sharing may lead to having two valence electrons here. So this sharing here can be referred to as covalent bonding. So if we consider the logic behind it is, let's say this is hydrogen, it is the valence shell of hydrogen, and it contains one electron, and this electron keeps on moving around this nucleus. This is another hydrogen, and then let's say there is another valence shell, there is another electron here, and if these two hydrogen atoms, they are basically sharing. So what we can do is we can draw them like this. These two are hydrogen atoms, so their electrons. Now these two electrons can move here, and then it can move here as well. So if we trace down the path here, what we can see is these two electrons are first cycling here. Then that means during this period for which these two are moving in this hydrogen atom, this becomes stable as it gains or it has two electrons. And when this pair of electron enters this atom here, so this basically enables or stables this hydrogen atom. Then that means for time being, this is also having two valence electrons. So that is basically the logic behind the stability here. Obviously, it can be clearly understood that by using this method of sharing electrons, it is very much clear that these two electrons, they are basically only moving for a certain period of time here, and then they are moving for a certain period of time here. But the idea is they were initially unstable. I was unable to buy this thing up. So by borrowing some money from some other person, I am now able to buy this up. Similarly, these two hydrogen atoms, basically they were initially not stable. Why? Because they were not having two valence electrons. Now for at least for time being, this hydrogen as well as the other part or other hydrogen atom, they are basically stable for a certain interval. Obviously this is no longer a better rule of stability. No one can say that this electron sharing is very good and is sufficient for the entire lifetime, but still it holds them stable for a certain period of time. So that is basically the idea of covalent bonding. So you can see this, that both of these two hydrogen electrons, they are basically carrying these two electrons momentarily, and that for that only moment they are stable. So this can be either represented this way, or this can also be represented this way, where we draw dash line here that represents electron being shared from between these two atoms, and they are basically stable by borrowing electrons from each other. So this dotted line or this line here, this solid line here, basically represents a single covalent bond. Now, what is a single covalent bond? What I would say is just remember this, that if we are considering here this whole cycle, each of the hydrogen atoms were basically providing one electron for bond formation. That means this hydrogen atom provided one electron here, and this hydrogen atom provided one electron here. So since each of these participant atoms are contributing single electron, so this bonding is known as a single covalent bond or single covalently bonded atoms. It might be a bonding between unlike atoms, such as, let's consider carbon. Carbon has four valence electrons. I'm using dots. Now, how would I know that it has four valence electrons? So that is again from the knowledge of periodic tables, and since it belongs to group 4, so all the elements of group 4, they have four valence electrons. Now, since it needs to have four more electrons to become stable, so if I provide this carbon with four hydrogen atoms, let's say one hydrogen atom, its valence electron, other hydrogen atom, its valence electron, other hydrogen atom, its valence electron, other hydrogen atom, and its valence electron. So what happens here? You can see this clearly that these four hydrogen atoms each are contributing one electron pair. So if we consider this pair, so you can see this hydrogen satisfies having two electrons in its valence shell for moment, and this carbon now is substituting or sharing electrons between four different consecutive pairs. Same goes here. So if they are sharing four different pair of electrons, so this carbon basically can have eight valence electrons, and this would lead to stability. So this can also be represented just by C, like this H, here H. So these single lines, they indicate single covalent bond between carbon and hydrogen. So we can write this as CH4, and we can write this as H2. So this is about single covalent bond. So we can relate the same process to double covalent bond and triple covalent bond as well. For example, if we are considering two atoms where each of the atom, double covalent bond, where each of the atom basically, let's say, provides or borrows two electrons from the other one. Let's consider oxygen, for instance.